Let's get started on your day 2 notes over verifying trigonometric identities. So in today's lesson, we're going to prove identities that require more steps than the previous lesson. So we're adding a few more helpful tips when verifying trig identities. Those helpful tips from yesterday were to try to rewrite everything in terms of sine and cosine. So for example, if I see tangent x, it would be a good idea to rewrite it as sine x over cosine x. And then we're just rewriting functions differently, and we're trying to set ourselves up to use a trigonometric identity. So, tangent x equals sine x over cosine x. We're just rewriting them. I'm rewriting tangent x as sine x over cosine x, and we're doing that with the entire equation. And then lastly, we want to start with the complicated side first. That's always a good idea. In addition to those helpful tips, I'd like to add that to add or subtract fractions, you must get a common denominator. And we did have to do that in some of yesterday's examples. Also, it can be helpful to get rid of a plus sign in the denominator. You can sometimes do this using conjugates and the fundamental trig identities. So, for example, what is the conjugate to 1 plus tangent x? It's 1 minus tangent x, and that's the conjugate. And lastly, all factoring, multiplying, and exponent rules apply. So let's go over a couple of those. Say, for example, I have ab squared. So two terms multiplied together. Whatever a is times whatever b is, all are squared. How could I apply the power rule to this? Every single term gets raised to the power of 2. A gets raised to the power of 2, B gets raised to the power of 2, every single variable. Also, let's say I have something like this, a minus b squared. What would that be? How could I rewrite that? That's a minus b times a minus b. And then what if I have something like, for example, sine squared x minus 1. That is a difference of two squares. Okay, what I just showed you up here, a minus b squared, that's not a difference of two squares. This is a difference of two squares. How could I factor that? That could be factored as sine x plus 1 times sine x minus 1. And these, notice, are conjugates. So we will be going over all of these types of things as we work through I've got 5 examples on here. So let's start with example number 1. Verify each equation using trigonometric identities. This says sine x over cosine x plus cosine x over sine x equals secant x cosecant x. So, I've got sine and cosine over here on the left, but I'm adding these fractions, which means I need to get a common denominator. So I'm actually going to rewrite this. So sine x over cosine x plus cosine x over sine x equals secant x cosecant x. And so when I get a common denominator, what should my common denominator be? Well, this only has cosecant or cosine, this one only has sine, so my common denominator needs to be sine x cosine x, which means I need to multiply this fraction over here times sine x. What I do to the bottom, I have to do to the top. This fraction over here, I need to multiply the denominator by cosine x. What I do to the bottom, I've got to do to the top. And now let's rewrite it. Now I've got sine x times sine x is sine squared x over sine x cosine x plus cosine x times cosine x is cosine squared x over sine x cosine x equals, and I'm going to go ahead and rewrite this. Secant x, that's the reciprocal of cosine. I can write it 1 over cosine x times cosecant x, that's the reciprocal of sine. So I can write it as 1 over sine x. And now I'm actually going to rewrite this, this sum over on the left side of my equal sign. Because I have a common denominator, now I can combine my numerators. So my numerator becomes sine squared x plus cosine squared x over, keep the denominator, sine x, cosine x equals, and let's go ahead and multiply these two fractions over here. 1 over cosine times 1 over sine is 1 over sine x, cosine x. So now when I'm looking at this numerator right here, what do you recall? What do you notice? That's an identity. What identity is it? That is a Pythagorean identity. Sine squared x plus cosine squared x is 1. And so you can refer to that table that we looked at yesterday. If you need to go back, I'll put a little card in the upper right corner for yesterday's lesson where we introduced those fundamental trig identities and worked through some more basic examples. So that's the Pythagorean identity, sine squared x plus cosine squared x, and that's 1 over sine x cosine x equals the same thing. And once we have worked through all of that, we have proven or verified this trigonometric identity, meaning what's on the left side of the equal sign is the same for what's on the right side of the equal sign for any value that I plug in for the variable. And remember, it's not the very last step that's important, it's all of these steps. We're proving it. So I need to show the logic and show the steps and the progression of the logic through this proof. Let's move on to, let's do blue for this one. Number 2, and we've got a different variable here. You might see x, you might see y, you might see theta, you might see b, you might see alpha, you might see anything, and that's fine, right? As long as we're looking at the same variables here. So secant y over cosine y minus tangent y over cotangent y equals 1. So let's just try to rewrite everything in terms of sine and cosine first. It's a good starting point. So secant y, that's the reciprocal of cosine. So I'm going to write 1 over cosine y over cosine y minus tangent y over cotangent y. Well, tangent is sine over cosine. So I'm going to write that, sine over cosine. And then cotangent is cosine over sine. So divided by cosine over sine. We're saying that's equal to 1. And now we're dividing this. This is like a complex fraction, which we're just gonna divide a fraction divided by a fraction, right? So multiply by the reciprocal. Keep, change, flip. So let's start with this first one right here. 1 over cosine y times, instead of cosine y over 1, we're gonna flip it. 1 over cosine y minus, and now let's rewrite this, sine y over cosine y, because we're dividing, keep, change, flip, so multiply by the reciprocal, not cosine y over sine y, but sine y over cosine y equals 1. And now what do we have here? Let's see, I'm going to use a different color. Let's go back to blue. And now in this first product on the left, 1 over cosine y times 1 over cosine y, well, that's 1 over cosine squared y minus, what would this be right here? Sine y over sine, or sine y times sine y is sine squared y over cosine y times cosine y is cosine squared y equals 1. And what do we have here? Now we're subtracting these fractions. We have a common denominator. Awesome. So we don't need to create a common denominator. We can just combine our numerators. 1 minus sine squared y, I'm going to write that, over cosine squared y equals 1. This right here is what? It's a trigonometric identity. So you have at your disposal, you know that sine squared x plus cosine squared x equals 1. And we proved that yesterday. We found how this Pythagorean identity was derived, right? We used the unit circle and we showed how we came about to determine that sine squared x plus cosine squared x equals 1. Well, I could rearrange this subtract sine squared x from both sides, and I would get cosine squared x equals 1 minus sine squared x, which is exactly what that is, which means 1 minus sine squared x equals cosine squared x, and it should be a y. So I can rewrite this as cosine squared y over cosine squared y equals 1. Anything over itself is just 1, and 1 equals 1. So let's move on to example number 3. And if you want, you can always number your steps. There was step 1, step 2, 3, 4, 5, and 6 to show. You don't have to do that, but sometimes when I'm going back and I'm like referring to notes, that is helpful. You know, in step 4, in step 3, we did this. Okay, let's start example number 3. Verify each equation using trigonometric identities. Okay, what is going on here? And actually, I'm going to change to this one. Okay, so in this one right here, I've got a fraction on each side of the equal sign. I see a couple things, 1 plus sine x and 1 minus sine x. Those seem very similar, but they're not the same. We do have a 1 plus sine x in the denominator in the fraction on the left. This is a great example or a great time to use a conjugate. Watch how I do this, okay? And I'm going to rewrite this so I've got a little room to show you what I'm doing. This is cosine x over 1 plus sine x equals 1 minus sine x over cosine x. What is the conjugate for 1 plus sine x? It's 1 minus sine x. And what I do to the bottom, I've got to do to the top to keep it proportional, right? So that it's the same value, right, in this fraction. So now, if I were to do 1 minus sine x times 1 plus sine x, and I were to multiply, you know, just like we did binomials, right? So this is like its own term, right? So 1 times 1 is 1. You know, FOIL it. 1 times sine x is sine x. 1 times negative sine x is negative sine x. So those cancel out. And then we've got negative sine x times positive sine x. And when I multiply all that together, I get 1 minus sine squared x. And guess what? That is a difference of 2 squares. And that's why we multiply by that conjugate. It's a difference of 2 squares. It eliminates those two like inner terms, right? The plus sine x and the minus sine x. So let's rewrite that. I've got in my numerator cosine x times 1 minus sine x over 1 minus sine squared x equals, and we'll just keep this over here. Whoops, 1 minus sine x over cosine x. And now I notice right here that this is something that we know. 1 minus sine squared x, and we just did it on example number 2. 1 minus sine squared x is what? Cosine squared x. That's a Pythagorean identity. So I'm going to rewrite it. Cosine x times 1 minus sine x over 1 minus sine squared x is cosine squared x equals 1 minus sine x over cosine x. Okay, we're still working through this, and I know what I need to get to. I need to get to this right here. Well, hey, I can simplify this cosine x over cosine squared x. Remember, that's like cosine x over cosine x times cosine x. What happens? These can be eliminated, and I'm left with 1 over cosine x, which is just 1 minus sine x over cosine x equals 1 minus, I did it again, sine x over cosine x. Boom shakalaka. And we just proved it. So if you want to write some notes on here, I would write here that we multiplied by the conjugate to create a Pythagorean identity. So we multiply by the conjugate to create a Pythagorean identity. And that eliminates that plus sign and that denominator, right? It eliminates the plus sign. We get a minus sign. And that's how we do that. So I would write that little, pause the video, make sure you've got that there, because when you're doing an assignment later on, you're gonna be like, now how do I do this? I'll be like, that's like example number 3. Multiply by the, oh, okay, yeah, that's what we did there. And again, if you want to do your steps, step 1, 2, 3, and 4. Let's move on to example number 4. We are rocking and rolling. I know yesterday's notes were a little bit long, but this, honestly, I mean, this can be really frustrating for students, and the more practice you have, the better you get, and that's just kind of how it goes. So in example number 4, sine x minus sine x cosine squared x equals sine cubed x. So what I'm going to do right here, just like, let's say you had something like 4x plus 2, I could factor out a 2, and I'd be left with 2x plus 1. Well, in this right here, I've got something in common, and that's a sine x. So if I factor out a sine x, I'm left with 1 minus cosine squared x, right? So a lot of times what I would suggest doing, if you're ever like confused because of all the sine, cosine, all these letters, right? As my students say, there's just too many letters. Write out what you know from Algebra 1. Okay, let's look at 4x plus 2, which we'll call this, each of them gets a variable, right? This is a minus a, b. What can I do? How can I factor that out? Okay, if I can do that with 4x plus 2, or I can do that with a minus ab, I can do that with sine x minus sine x cosine squared x. Okay, so I'm going to put a little note here. We factored out sine x. That's a good little note. Moving on to the next step. So now I know, because we've done this so much in yesterday's lesson and today's lesson, 1 minus cosine squared x, I can rewrite as what? That's a Pythagorean identity. And what's that identity? 1 sine squared x plus cosine squared x is 1. I can rearrange it so that 1 minus cosine squared x is sine squared x. Pay attention, that does not say cosine squared x minus 1. That's different. So if you're ever confused, I would off to the side, write out your sine squared x plus cosine squared x equals 1, and then rearrange it, because you can rewrite this as sine squared x equals sine cubed x. And now I can simplify. Sine x times sine squared x is sine cubed x. In our last and final problem, we've got a lot going on here. Sine y plus cosine y all squared divided by cosecant y equals tangent y divided by secant y times 1 plus 2 sine y cosine y. Okay, there's a lot going on here. The first thing I'm going to do is just rewrite everything that's not in terms of sine and cosine in terms of sine and cosine. So let's go ahead and start with this. We've got sine y plus cosine y squared divided by, and then cosecant y, that's the reciprocal of sine. So I'm going to rewrite that as 1 over sine y equals, let's rewrite tangent and secant. So how would I rewrite tangent y? As sine y over cosine y. And then secant is the reciprocal of cosine. So I'm going to rewrite that as 1 over cosine y. And then let us not forget times 1 plus 2 sine y cosine y. Okay, next step. When I'm dividing these fractions, these look like complex fractions. When I divide them, I'm going to multiply by the reciprocal. So I'm going to go ahead and rewrite sine y plus cosine y squared over 1 times, and I'm going to flip 1 over sine y. So I get sine y over 1 equals, and then let's go ahead and rewrite this fraction on the left the same way. I'm going to rewrite sine y over cosine y, and it's just keep, change, flip, times, instead of 1 over cosine y, I'm going to write cosine y over 1. And then we can't forget times 1 plus 2 sine y cosine y. Okay, and we're just doing like a little bit at a time, right? Okay, so the fraction on the left, I've got sine y plus cosine y squared times sine y. At this point, you know, what I'm thinking of doing is I'm kind of looking at the one on the right side of the equal sign, and I can easily simplify this right here, right? Can't I do that? Sine y over cosine y times cosine y over 1. So I'm left with sine y times 1 plus 2 sine y cosine y. Okay, so the one on the right, I'm thinking at this point, I need to go ahead and rewrite that sine y plus cosine y squared is sine y plus cosine y times sine y plus cosine y. And these are just two binomials, and we need to FOIL them. Okay, so this term plus this term plus this term. So let's go ahead and FOIL them. First, outside, inside, last. Well, I didn't mean to do that. Cosine y, and then here's sine y. Okay, so let's go ahead and do that. First terms, sine y times sine y is sine squared y. Outside terms, sine y times cosine y is plus sine y cosine y. Inside terms, cosine y times sine y is just another sine y cosine y. And then cosine y times cosine y is cosine squared y. So let's go ahead and rewrite this. Sine squared y plus, if I have two of these terms that are the same, can I combine them? Sure, right? It's just basic algebra, and that's honestly where I see a lot of problems with my students, is just in that basic algebra. Are they the same terms? Yes. Then can you combine terms that are the same? Sure. How many of those terms do you have? I have 2. Plus 2 sine y cosine y plus cosine squared y. Okay, what are we going to do at this point? Now, this is all addition, which means it's commutative, which means it doesn't matter the order in which I add. So could I rewrite it like this? Would that be okay? Would that still be the same amount? Sure. And then what do you notice? Anybody notice something with this right here? Sine squared y plus cosine squared y, that's a Pythagorean identity. What is that identity? Or what does it equal? Sorry. Sine squared y plus cosine squared y equals 1. So I'm going to rewrite that part as 1 plus 2 sine y cosine y. And then look what we got here. We can now rewrite this as 1 plus 2 sine y cosine y times sine y, which is the same. Done. You proved it, and we are finished with these day 2 notes over verifying trigonometric identities. I hope it was helpful. I know it's tough. Just keep on practicing, keep on doing them. You will get better. Good luck.